Hi, so in this video we'll talk about multiplying polynomials and then using the FOIL method in the circumstances where we can if we want to. So first, we have multiplied polynomials before. We just didn't call them that. Whenever we learned how to do the distributive property, we basically multiplied polynomials. We also haven't had to use the distributive property with our rules of exponents that we learned back in class a couple of weeks ago. So we're going to kind of combine the distributive property with our rules of exponents and then combining like terms to be able to multiply polynomials. So let's do an example of this. Again, this is something we know how to do. We just haven't quite done it like this before. Okay, so let's look at multiplying these two polynomials. So in this case, we have a monomial, so just a term, times a binomial, two terms in that polynomial. So we're going to use the distributive property to multiply the monomial by each term in the polynomial. And what we're going to end up having to do is use our rules of exponents. So if we multiply 4x times x squared, and we have our plus sign here, we also need to multiply 4x by 5. Okay, whenever we used the distributive property before we had to use our rules of exponents, we talked about we would multiply the coefficients together and then the variables together. So that's what we're going to do here. The coefficient here is just 1. And so if we multiply our coefficients together, we just get 4 times 1, and that's 4. And then if we multiply our variables together, this is a case of where we have x times x squared. So these are two expressions with the same base, and they're multiplied together. So what we would do is add their exponents and keep that same base. Still have our plus sign. Over here, we only have one term with a variable in it, so we don't really have to worry about our rules of exponents. We're just going to multiply these two numbers together to get 20. And then we have our one variable that's there. So just to finish up, this ends up being 4x cubed plus 20x. And what we would normally do here is try to combine like terms, but there aren't any like terms here. This is an x cubed and that's an x, so we're done. Don't feel tempted to factor this if you've done that in another class. This is your answer. You have multiplied and you have simplified as much as possible. So don't try to factor it. You're just going to be working backward. Okay, so let's do another example. In this one, it's a little bit longer. We have x squared minus 3x plus 4 times x minus 2. Now, we have more terms in this polynomial than we did in the last one. Obviously, this one has 3. The last one had 1 in the first polynomial. And in this one, we have 2. But we're going to do exactly the same thing we did before. We're going to use the distributive property, then use our rules of exponents, and then collect any like terms if we have them. So let's start by distributing. We're going to start by multiplying everything in that second polynomial by x squared. And let's see what we get. We have x squared times x, don't forget the plus sign, x squared times negative 2. Okay, so that does it for x squared. Now we'll do the same thing for minus 3x. So don't forget your plus sign. We do minus 3x times x, plus sign, minus 3x times, and I'm running out of room. Let's see if we can make that a little bit smaller. Times minus 2. One more, we have to distribute the 4 through, so don't forget your plus sign. We're going to do 4 times x. Don't forget your plus sign, and 4 times minus 2. And that's a lot. But let's see what we can do when we put all the things together using multiplication. So here we're going to have to use our rules of exponents. That's going to end up being x squared times x to the first. So we're going to keep our x and add our exponents together. So that's going to be 2 plus 1. That gives us 3. Now, negative 2 times x squared, there aren't any real coefficients to put together. There aren't any variables to put together. So the most we can do is just write these two pieces next to each other. And you're welcome to call that minus 2x squared. I just put it like that so it's consistent. Now let's look at these two terms. The only coefficient we have that's not 1 is negative 3. So that's the one we're going to end up with. And we have x times x. So we're going to keep the base and add the exponents, 1 plus 1. Next, we have a negative 3x times a negative 2. We can multiply our numbers together to get 6. And x is the only variable involved there. Here, similar to here, we just have a 4 and an x, so that's going to be just plus 4x. And then finally, plus what ends up being negative, that's a negative 8 over there. Oh, geez. Okay, now let's see what we could put together using like terms. We have an x cubed, and I don't see any other x cubed, so it's going to have to stay by itself. All right, I have a minus 2x squared and a minus 3x squared that match. Put together the coefficients, and I get minus 5x squared. I have a plus 6x and a plus 4x. That'll give me a plus 10x. And then finally, the minus 8 is our only constant there, so that one has to stay. And we're done. That's it. We multiplied everything in one polynomial by everything in the second polynomial exactly one time. We used our rules of exponents to get everything down to a term, and we gathered up our like terms. So that's it. It was a lot longer, but really the process was the same. All right, we are going to skip the one with 3 because quite honestly, it's not worth the trouble, and I don't think this board is big enough. So let's go to the FOIL method. Okay, now the FOIL method is not different from the distributive property at all. It's exactly the same thing. It just is for use whenever you have a binomial times a binomial. So for instance, if you're doing x plus 2 times x minus 5, that's when you would want to use the FOIL method. FOIL stands for firsts. So you'd want to multiply these two terms together first. O stands for outers. So we'd want to do the outside terms next. So you'd want to do these two together next. I stands for inners. So the inside terms, these two. And then L stands for lasts. So the last terms in each factor, this one and this one. And if you look at it, it looks just like the distributive property because that's all it is. However, it's nice to know this because it's going to help us in the next section when we start to factor these. It'll be nice to know how they were kind of unfactored to be able to break them apart again. So we'll practice using the FOIL method in the next few examples, but just keep in mind, if you just want to think of it as the distributive property, that's okay. All right, so here's our first one. Let's look at x plus 3 times 2x minus 1. All right, well, using FOIL, first of all, we can use FOIL here because we have a binomial times a binomial, and that's what the FOIL method is for. So let's go with it. Firsts, x and 2x are the first terms in each factor. Outers, x and minus 1 are the ones on the outside. Inners, these are going to be the two on the inside. And finally, lasts, which you can barely see, which are going to be our last terms, 3 times minus 1. So now let's look at what we've got when we put these together. We have 2x squared minus 1x, or just minus x, 6x minus 3. these two terms are like, so we can put them together for 2x squared plus 5x minus 3. And that's what we get whenever we distribute these. And again, we could use the FOIL method here because it was the product of two binomials, so two two-termers. The FOIL method works for us there. All right, the FOIL method also works if we don't just have polynomials in one variable. So we could have polynomials in two variables. And so long as they are both binomials, x minus 3y. I was looking at the last one. As long as they are binomials, this is something we can use the FOIL method for. All right. So first, look at the first term in each factor. Outers, look at the terms that are on the outside of each factor. Inners, look at the terms that are on the inside. And last, look at the last term of each factor. And then just like before, we're going to put these together and see what we can combine. So x times x is x squared. X times negative 3y. Well, all we can do with the negative 3 is put it together with the 1 that we don't see here to get minus 3. X and y are different bases, so the most we can do is just write them next to each other. Here, y and x are different bases, so the best we can do is write them next to each other. And then finally, we can put this minus 3 together with this 1 to make a minus 3. And y times y is y to the 1 plus 1, or y squared. Now we would look for common terms or like terms, and we have them. This one contains an x and a y. This one contains an x and a y. Now notice I wrote this xy. I think it was because it was just out of habit, but I could have called it yx. They still would have been like terms because they still would have contained an x to the first power and a y to the first power. So we can put these together and you can order the variables however you want. But this would be x squared minus 2xy minus 3y squared. All right, so using the distributive property is fine. Using the FOIL method is okay if you want to, when you can. So let's look at one more of these just so you know what you're not allowed to do. Okay, so for something like this, first of all, we already know, and I think we mentioned it in the rules of exponents lesson in class, that we don't have a rule for a sum or a difference raised to an exponent. We don't have a way that we can distribute that to, it's very tempting to just call this x squared plus 16, but that's not correct. So don't do that. If you ever have a situation like this, what you need to remember is what this 2 up there means. It means that we have 2 factors of whatever the base is. And in this case, the base is x plus 4. And now it looks like something we could use the FOIL method on, and we're going to. Just please remember that this is something you have to do. You are not allowed to distribute that to ever, ever. Okay, so now let's use the FOIL method. So we have x times x, and I'll just keep taking this slow. If you can skip this step, please do. X times 4. 4 times x, and 4 times 4. And now let's clean that up and see what it actually is. So x times x is x squared. 4 times x, there's nothing much we can do with that except just write them together. Another 4 times x. And then 4 times 4 is 16. So these two are going to be like terms. We can put them together. And we end up with 8x in the middle. So notice what would have happened if you had tried to distribute that square. You're not supposed to. And the reason why it's wrong is because it leaves out this middle term right here. So you'd be missing out on this and you'd end up with something that's incorrect. So anytime you see a sum or a difference raised to an exponent, FOIL it out, distribute it out.